Hi, I'm Skylar Swinford. I'm out at the Karuna project. I'm going to talk real quickly about the domestic hot water system. Jonathan discussed the hydronic side of the system and the zonal heating side and how the hydro box worked with the heat pump. I'm going to talk more about the hotter water, which is actually made separately. Instead of being in the 70 to 90 degree range like the low temp radiant system, this water is actually 120 degrees, and it does all the hot water for showering and cooking and all those needs in the home. The cool thing is it's still utilizing the heat pump system that the low temperature radiant floor system is, but it's still producing energy, the hot water in the tank at a similar coefficient of performance that you would get in our climate out of a solar thermal system. So typically we think in the passive house world is solar thermal being the optimal choice for hot water, and certainly in many cases that is, but in our case we already had the Altherma system as part of our hydronic system, so we were able to, for a minimal cost, add this storage tank module to it for similar performance and cost. One of the key parts of the performance is not only the 300% nearly efficiency that we get out of heating the domestic hot water, but it's really in the distribution. And you find when you're doing that energy modeling for a very low load house that when you're taking into account the line losses that you can get from an inefficient distribution system, that it makes a huge impact on the overall energy use, because in a passive house we've really reduced the heating and cooling load down to very, very low numbers, like 90% less than a typical house. And so the hot water function becomes a very important part of the picture. And in this project we're shooting for net zero energy. So we wanted to take an efficient energy source, which would have been a solar thermal. In our case, we're using the heat pump, the air to water heat pump, to really produce efficient hot water, and then we're distributing it as efficiently as we can. And this is a really big house with a few wings, and so it doesn't have the most ideal domestic hot water layout. In a typical passive house, we'd really prefer the mechanical room to be at the core of the building and have really short distribution lines, so that way we're not leaving a bunch of hot water behind after every water use. In our case, what we've done is we've insulated all of the hot water lines very well with closed cell insulation. So when you get clustered loads where, let's say you wash your hands in the morning and then you go jump in the shower, the water line is still primed and hot and ready to go, and we're able to reduce the amount of heat loss out of the pipe. We also have another cool feature, which is this recirculation pump. In a traditional recirculation system, they have a bad connotation as being an energy hog, because they just run 24/7 and you're constantly taking heat from the hot water tank, pumping it in the lines, and then it cools in the lines, and you basically have wasted all of that energy. And so with this system, we have a demand control. And so rather than running for hours a day or on a timer where it runs for another strategy is to run for a couple hours in the morning and a couple hours in the evening. Rather than doing even that, we have this demand system where we have a motion sensor that we'll show you just in a little bit, where when you walk into the bathroom, it primes the line and it gets all your hot water. So as soon as you go to your tap, you have hot water. And so that's a more energy efficient way to have hot water on demand. And also it's going to save water because you're not keeping your tap running, waiting for the hot water to come, which would result in unnecessary wasted water. So now we're up in the master bathroom, which is a couple flights of stairs up from the mechanical room that we were just at. And you can see up on the roof here that we have that small little motion sensor. So basically what happens when, if there hasn't been a demand for water in the lines, so there's no hot water primed at the sink, basically you step into the bathroom, that activates the pump, and really quickly that primes the lines with hot water from the domestic storage tank that we saw in the basement. And as soon as you go to the tap, turn it on, you get hot water virtually instantly. The same would go for the shower, so there's no more turning the shower on and waiting for the water to get hot and wasting that water down the drain. And from an efficiency perspective, that pump's really working just a short period of time, and it has a temperature sensor. So if someone used the sink earlier and we came back in here like an hour later, the line is still probably plenty hot and that pump's not even going to run. So super efficient, really convenient, great feature of the home.